Okay, so lesson 36 is on vectors. So it starts out pretty basic. We're just doing a little introduction today. And a vector is something that has both what we call magnitude and direction. So there's going to be like a certain, sometimes we call it a directed line segment. It has basically a certain length to it, that's the magnitude, and a direction. So it's going to point in a certain direction. Does that make sense? All right, so an example would be, as Alex likes, the speed of planes. That will end up being the magnitude. And the direction that they're flying often called bearing. You guys remember we talked about bearing before. So in this example, it says the point 2, 3 represents the position in the coordinate plane, but the vector, see how it has like the little vector, like these little triangular things? The vector 2, 3 represents a directed line segment with its tail at 0, 0 and its head at 2, 3. Okay, so it goes from here, from 0, 0 to whatever point we're talking about. So in this case, I was calling it 2, 3. Okay, so that ends up creating the vector, which we do like this with those little pointy things on the edge. Okay, so if we're talking about the magnitude or length of a vector can be found very easily. So let's say I have one where this is the vector 3, 4. How do you think we find the length of this that I just drew? What do you guys think it would be? Pythagorean theorem, right? Because I would go over 3 units and up 4 units to get to the tip of that directed line segment, that vector. And so it would end up being 5 units there. So all it is the Pythagorean theorem. That's how you find the length. Easy enough? And the direction is found kind of in a similar way. You just draw a sketch and you say, okay, well, I go over to the right 3 and I go up 4. So if I want to find this angle theta in here, all I would do is set up tangent of theta equals 4 over 3, and I would solve it, right? I would do inverse tangent, and so on. But I will say that the biggest mistake that pre-calc students and physics students will make is that they just kind of do it on their calculator. They just take whatever answer makes sense. You always have to think about what quadrant you're in. Because do you remember a tangent has like a period of 180 degrees? So if I had drawn, let's say like -3, -4, if that's my vector, my calculator is going to give me the one in the first quadrant. So you have to be very, very careful. So I always draw sketches. All right, so it says vectors can be written in several different ways. Sometimes we use a bold letter to represent a vector. Sometimes we use a little ray symbol above the letter instead of bolding it, like this. Sometimes it kind of looks like that too. There's lots of different ways to write it. Other times we use the letters I and J to represent the X and Y coordinates. That's the one that I always hated when I was in school. So if you see something like -2i plus 3j, it's really the vector -2, 3. Okay, does that make sense? So you're going to see lots of different notations. And basically it's because there are lots of mathematicians working on vectors at different times, well, kind of at the same time in different locations, using the different notations. Okay, and that happens in calculus too. We have lots of different notations in calculus, which can be frustrating. So they're all the same thing. So I'll try to go back and forth between all of them so you get familiar with all of them. All right, so the first one, it says sketch the following vectors and then find their directions and magnitudes. If needed, round angles to 3 decimal places and give answers between 0 and 360 degrees. Isn't that nice? I'm letting you go back to your favorite degrees instead of radians. All right, so as we draw this, we have 5 to the right. We go down -12. So our vector that we're going to draw in looks like that. Okay, it always starts from the origin and goes to that end point. So in order to find the direction and magnitude, the magnitude is just the length. Okay, so the way that we represent the magnitude is we do like little absolute values around the vector. Oops, that's a 5, right? +5, -12.
Why do you do that?
That just means length. That's the way we represent length. Sometimes you might see it as like 2 lines too. Just to confuse you even more, right? So if I had written like u equals whatever, then I could just do like the magnitude of u. But I forgot to write the u equals. All right, so if I do that, it's going to be the square root of 5 squared plus -12 squared. Do you guys know what it's going to be?
13.
Yeah, exactly. So our magnitude is 13. So if you want to write magnitude equals 13. All right, and then if I want to get the direction, I need to figure out what that angle is. So here's where I draw my little angle, right there. Okay, I want it between 0 and 360, so it's really from here over. That's really where your theta is.
Oh, I
All right, but we set it up and we do tangent of theta equals the y value divided by the x value, right? Because it's opposite over adjacent. That's all we're doing, opposite over adjacent. So we have negative 12 over 5. So take your calculator. We switch it to degree mode. So hit mode and switch it to degrees. And we do inverse tangent of negative 12 over 5. And when I do that, I get,
67.
is it exactly 67?
No.
Negative 67.380. Oh, she even remembered that I like
But why?
3 decimal places.
Oh, I forgot the negative.
All right, I see. So the question is, well, how do I figure out what that is on 0 to 360? What do you think?
Don't tell me to use a circle.
No, it's not the unit circle. We just add 360 degrees. It's just finding like that coterminal angle. So if I add 360, you end up getting 292.620, we'll say, degrees. That is the direction.
Oh, shoot.
All right, you guys understand that? So you can add like 2 pi. It's like adding 1 period to it. Or no, actually 2 periods there. Is it pretty easy? You guys understand it? It's not so bad. All right, so let's say I have this one. So I have 1 comma root 3. So if I draw the picture, I go over 1, I go up root 3. It's going to look like that. You can kind of draw on your measurements if you need to. 1 root 3. I did this one for a reason. It's actually a unit circle one. You could do it. Think about if you have a triangle and you have 1 and root 3. Think of it like 1/2 and root 3 over 2. Do you guys know the angle that would be here? 60 degrees. So sometimes you can get it without even doing like the tangent of theta equals whatever. Like I could see right away that that's 60 degrees. So some of you guys will be pretty good at that. Some of you guys will need to write it out. That's totally fine. All right, so if I do the magnitude is going to be the square root of 1 squared plus root 3 squared. So it's going to be the square root of 1 plus 3, which is the square root of 4. Yep, so we get a magnitude of 2. Does it make sense that you would have a 2 here? Well, not really. It's a 2 over 2 in that case. It's a 30, 60, 90 triangle, right? It makes sense that it would be a 2 there. That's the length of that side. All right, and then the tangent of theta, our tangent theta is going to be opposite over adjacent, right? Here's our little theta. I can't really draw it very well in my picture. Picture's so tiny. And we know that. We know when tangent of theta is equal to root 3 because it's the one where it's tangent of theta equals root 3 over 2 divided by 1/2. Or you could do your calculator, right? And do inverse tangent of root 3. And your calculator will give you 60 degrees. Isn't that nice?
420.
Do you add 360 to it again?
Do you?
Do you?
I don't
Mine
know.
got 60, so you just.
It's just 60 then. Okay, do you guys see why it would just be 60?
Do you only have 360 when it's negative?
You only, well, this looks like it's at 60 degrees, right? You want to think about where it looks like it's located. Do you guys see it? 60 degrees, that worked for us. But if I said negative 67, yes, that's in the right location, but I want my answers to be between 0 and 360. Okay.
Oh,
All right, next up. Okay, this one looks different, doesn't it? Does that bother you that it looks different? That's what I was saying. I didn't like when I was in school. I hated when it had i's and j's. I'm like, just give it to me like in vector form, component form. All right, so it's going to be negative 2 comma negative 6. That's the same thing. It's exactly the same. If you want to write it that way, just write it that way.
Oh, hot dog.
So you're going to go negative 2 and then down 1, 2, 3, 4, 5, 6. So here's your vector. So what do you think theta's between? Theta's between 180 and what? 270, right? It's in that third quadrant. So we want our answer to be between 180 and 270. All right, let's find the magnitude first. The magnitude is equal to the square root of negative 2 squared plus negative 6 squared. So we get 4 plus 36. So square root of 40. Would I write it as square root of 40, you think?
No.
Yeah, so you can break it apart as square root of 4 and square root of 10. So it would be 2 root 10. To simplify.
Then we gotta find
And then the direction, if I do tangent of theta equals the y over the x, yeah, I get tangent of theta equals 3, so theta is equal to inverse tangent of 3.
Oh, 71.
Yep, so it's going to be 71.565. Did you guys all get that?
No, because it's not.
So, I don't know, do we? Where do we say we want our theta?
It's not between
Our theta has to be between what two measurements?
180 and 270.
Yeah, it has to be between 180 degrees and 270 degrees, right? Because we want this measurement right there. That's our theta.
Oh.
So what should we do? Yeah, add 180 because the period for tangent is 180. So I'm just adding one of those periods. So if I add 180 to my answer, I get 251.565 degrees. Does that one make sense? It does. You're good. And then some of you could do without even doing any math.
0.
Think about this picture. 0, negative 4. 1, 2, 3, 4. It's going to be right here.
270.
Yeah. Yeah is correct. It's 270 degrees. What is the magnitude? Magnitude is 4. That's it. So your magnitude is equal to 4, and the theta is equal to 270. Do you guys all see how we got that? We just sketched it out.
That's brilliant.
Yeah.
Right? But you could do all the formulas and you would get the same thing. So you could do the formulas, just kind of remember that you're probably going to get like 90 as your answer, so you'd have to add 180, so it's really 270.
Can I get extra credit for that?
No, you just answered a question right. I was proud of you. All right. Yes. Because you have a choice between 180 and 360 to put it where it's going to be. It's like if I always add 180 and see if it's where it needs to be, and if it's not, then I add it again. So in that first example, I added 360. I really should have done 180 twice, so you can see that. Because the period of tangent is just pi. All right, so it says vectors don't always have their tails at the point 0, 0. Vectors could be all over the coordinate plane, and we can move them wherever we need them. So we move them around a lot. This is going to make more sense as we're adding vectors and so on. So suppose we have the vector 3, 4. Okay, it says sketch this vector with its initial point at 0, 0, and sketch 3 different forms of the vector with different initial and terminal points. So I could have the vector 3, 4 right here, but it didn't have to start there. It could have started wherever I wanted it to. Okay, the exact same, so I want it to point in the same direction, and I want it to be the same length. Couldn't I draw it like, I don't know, here? Pointing in the same direction with the same length? That's an equivalent vector. They're exactly the same. Okay, but what if I decided I wanted to start at a random place? -3, well, let's do -4, -2. Let's say I started there. And I still want to go in that same direction and have the same magnitude, so I would still kind of, from that initial point, I would go up, I'd go over 3 and up 4, right? 1, 2, 1, 2, 3, 1, 2, 3, 4. That would be the terminal position. So another vector would be like right there. Does that make sense? It has the same direction, same magnitude. Do you see how it looks like the same vector, it's just moved? That's all we're doing. Can you find any other one? Doesn't matter where you start. So what about if I started here and I went over 3, up 4? Right, that would be a third vector. These are equivalent vectors. Okay, so it says, for example 1, it says find the vector A, B. So we're going to write it in vector form with the little triangle things on the end, with points A, which is -2, 0, and B, which is -6, -7. So let's sketch it out and then talk about what the pattern is. So if I have -2, 0, here's where A is. That's its initial point. And then I have -6, -7. 3, 4, 5, 6. I didn't plan ahead on this, did I? So I get that. Should really connect with that point. Okay, that's my vector.
Wait, so where would you label B, the B point?
B is at -6, comma -7. Right? B is right here.
Oh, okay. Yes, sir.
So go over to -6 and down to -7. Okay, now if I move that vector, if I moved it over here and had the same length, same direction, it would have a new name, okay? This would be our vector AB. We usually write it kind of in standard form. So what would I do? So where does it end? How much did I go over and how much did I go down? I went over to the left how much? -4. And then down 7, right? So that means that this red vector that I drew will have to go to the left 4 and down 7. So its component form is -4, comma, -7.
Wait, so
You're drawing it using the initial point of 0, 0. We're just moving it to 0, 0. You're going to be moving vectors all over the place. So a convenient place to have it is at 0, 0.
oh, I see.
So this is what we would call an equivalent vector. It's exactly the same as the other one. It's just been moved. Okay, so if I have -4, comma, -7, how could I use, I don't know, how do I start with this and get this? What's the pattern? What do I do? Like, any guesses on this next one?
Oh, wait, are you just talking about like 12, 14?
I don't see where you're getting the 12.
Me,
Oh, I had way too much.
God.
10.
Don't guess. Crap.
Guesses on what?
What do you think this new vector will be? So we can sketch it out. So it's fine if you need to sketch it out, it's fine. So I have -3, comma, 1, 2, 3, 4. So that's my initial point right there, C. And then it goes to 5, comma, -10. So it goes down there. So the vector that I'm drawing looks like this. This is, CB. Is that what it is? That's vector CB. But usually when I talk about vectors, a lot of times I like to have kind of that standard vector starting at 0, 0. So if I started this at 0, 0, and it had the same direction, right, the same angle, and the same magnitude, it would look, whoa, that one's kind of wobbly. It would not look like that. It's going to look something like that. Does that make sense? It has the same length, same direction. It's pointing the same way. Does that make sense? How would we find that length? So how much did I go down from C to go down to B?
6.
More than that. I went down 14, right? I was at a height of 4 and I went down to a height of -10. Okay, and then what about going over? I went over from a height of 3 to a height, or not a height, an x value of -3 to an x value of +5. I went 8. So if I was doing the same thing with this one, it would be, the component form would be 8, comma,
14.
-14. Close, because we're going down 14. Maybe I should put a negative there. All right, so it's going to be 8, comma, -14. So there's a very easy way to do this. Do you guys see the pattern? What are we doing with these numbers that we had originally? We're taking the difference, but which one comes first? Which one comes second? x2 minus x1, and then y2 minus y1. Does this make sense? Do you guys understand that? So it's always x2 minus x1. I like the way he said that. The second x value minus the first x value. y2 minus y1. Okay, we call this the tail to tip. Tail to tip. So take your tail and subtract out the tip. So what do we think this one would be then? -7, comma. Oh wait, not -7. You messed me up now. You're thinking of slope. 0, comma, -7. Right, it's going to be the first one, 0, comma, -7, minus the second one, if you want to write it out that way.
Hamburger.
And that would be our vector EF.
Yes.
Okay? So it says if an arrow has initial point x1, y1 and terminal point x2, y2, it represents the vector, right, starting at 0, 0, x2 minus x1, comma, y2 minus y1. So number 1, it says find the component form. Whenever it says component form, it just means like x comma y. Like it's always going to be like x, y. That's what component form means. Of each vector, and then find their directions and magnitudes. So the component form, we want to say, what if it did start at 0, 0? If it started at 0, 0, here's what it would be. All right, so if it started at 0, 0, so let's look at v. V is the easiest one because it does start at 0, 0. What point does it go to? It goes to -9, comma 8, right? So that v is easy. Its component form is, put it in vector like notation with the little pointy ones like that, -9, comma 8. Okay, what do we think its direction and magnitude would be? So if I find its direction, that's its theta, right? So I do tangent of theta equals opposite over, or not, yeah, opposite over adjacent. It's the y value over the x value. And then we do inverse tangent on our calculator. So get your calculator out and try it. And we get theta equals -41.633. Do we think that's what this angle is right here?
We gotta get
No.
380.
You add 180.
Yeah, add 180 to it. Let's see what happens. Do we think it looks like 138.366? Yep, I think it is. All right, and then its magnitude.
Ms. Cox, how did you get, I think you switched it to decimal.
What did I do?
You had 0.633 and
Oh, yeah.
0.36.
Well, no, I added.
Okay.
Yeah, because they add up to be 999, like 0, 0, 0. Yeah, thank you, though. All right. So the last one should have been 0.634, I guess. That would be the more precise answer. Does that make sense? 634. And then plus. All right, so magnitude. So magnitude is just Pythagorean theorem. If I draw like straight down, straight over, I could easily find what this length is right there, right? That's what I'm doing. So Pythagorean theorem, let's do it. So I'm going to have the square root of 8 squared plus -9 squared. So it's the square root of 145. Does that go down at all?
No.
145. If I divide 5 into it, yeah, it's 5 and 29, so it doesn't go down anymore. So we're good. So the direction and magnitude are these numbers. Okay, and we would do that for each of these. Do you want to do one more? Let's do another one where we have to like think about where it is. So y is a good one. So if I have y, okay, I first need to identify what the tail is and what the tip is. Okay, do you guys know what those 2 points are? 1, comma 8, or -8, I guess. And then the other one is -5, comma -2.
Oh no. Oh yeah. We can use that one thing.
I guess I should say head minus tail. I'm saying this wrong. Head minus tail. So the 1, comma -8 minus the end. So I'm going to get 1 minus a -5. And then I'm going to have -8 minus a -2. So I end up getting 6, comma -6. Okay, so think about that. If I started from 0, 0, and I went over 6 and then down 6, does that look like it goes in the same direction? Has kind of like the same slope as the other one? That's the way you can always check. Does it look the same? Yeah, are you freaking out? You good?
I don't freak out.
Your face looks like you're freaking out.
No.
So we're good. So let's find its direction and magnitude. So that's the key. You have to get that first, though, before we can do the other questions. So it's direction. we're going to have tangent of theta equals negative 6 over 6. Well, that's kind of nice. We have tangent of theta equals negative 1. You can do that on your calculator, but I think you guys know where tangent is equal to negative 1.
45.
Yeah, it's actually negative 45 degrees. So your calculator will give you negative 45 degrees. It will give you an answer between negative pi over 2 and pi over 2, remember? So you can do it. So if you do inverse tangent, you can check, of negative 1, you get negative 45.
And that's okay to keep.
I would do between 0 and 360.
Okay.
So if you want between 0 and 360, let's add,
180.
if you add 180, you get 135. Is that where we want it? We want it to be like this angle here,
Add 360.
right? Let's add 360. So plus 360. I don't know why I'm doing this in my calculator. So I get 315 degrees. Does that make sense? All right, and then what about the magnitude? So the magnitude is going to be 6 squared plus negative 6 squared. So he's saying square root of 72. Do we leave it like that?
No.
How do we write it?
2, 7.
Right.
2 root 7.
No.
With that.
What's the biggest square root that goes, or the
3
biggest
root 7.
perfect square that goes in there? 36 goes into it. So if I have square root of 36 and square root of 2, 6 root 2. You were really convinced it was that other one, weren't you? All right, does that make sense? I'm not gonna do all 4. Do you guys get how it works? So you wanna find like the basic, like I would say like the standard vector, the one that starts at 0, 0, and then do all of that stuff to it.
Can you 6?
So it says sometimes vectors don't have the same components, but they have equivalent lengths and directions. That's what we just talked about. So when this happens, vectors are said to be equivalent. They're exactly the same vector. I know that's super confusing because you're like, it's not in the same spot. Like, how are they the same? But vectors can move wherever, right? A vector is basically like, we're going to use it for things like wind. Can wind be starting at any location? Is it probably going to blow pretty much in the same direction? Yeah, for the most part, unless you're like in Indiana and Oklahoma. I don't know. Maybe they're not the same direction then. But if you're pretty close to the same area, it's blowing in a certain direction with a certain force to it. Okay, so it says, for instance, the vectors A, B, and C, D are equivalent vectors. They're both equivalent to vector V. Do you guys understand this concept? So if I give you a list of points, will you be able to figure out if A, B, and C, D are equivalent? So if I have A, B, and C, D, so let's do the head minus tail. I always called it something else in school. So head minus tail, we'll call it this. So if I do A, B, we're going to start with this one and subtract out that one. So we're going to have 0 minus a negative 2, and then we're going to have 4 minus a 0. So we end up getting 2, 4. All right, what about CD? CD, we're going to do the D minus the C. So we're going to have negative 1 minus a negative 3, and then we're going to have 3 minus a negative 1. So we end up getting 2, 4. Are they the same?
Oh, they are the same.
They are the same. So they are what we call equivalent vectors. So if I had sketched out the pictures, you would see that they go in the same direction and they have the same length. Does this make sense? All right, so adding and subtracting two vectors is exactly what you think it would be. It's super simple. Adding and subtracting vectors. So if you have u and you have v, and I ask you for u plus v, what do you think you do with their x's and y's? You just add them together. That's it. So it would be u1 plus v1, comma, u2 plus v2. And then the product of a scalar k and a vector u, it's going to be like k times u1, u2. What do you guys think happens when you multiply that k in? It's just k u1, k u2. Does that make sense? Okay, all that does is it changes the length of your vector. So if your vector was like 1 unit long and you multiply through by 12, it's going to be 12 units long. Okay, it says there are two different geometric representations of vector addition. So one is called the tail to tip. It got moved over there. Tail to tip representation. In this representation, we move the second vector to the end of the first vector and then draw a line from the tail of the first vector to the tip of the second vector. So basically, if I have, let me see what I'm trying to. So if I'm doing A plus B, what am I trying to do here? Let's say B plus A. Okay, I'm going to take, well, hang on. I want to make sure that I do it the way I do another way. Okay, so if I do A plus B, so it says you take the second vector to the end of the first vector, and then you draw a line. Okay, so really, if I had A plus B, what would happen is you have A, and then you move B, see how B is like that? You move it to the end, and then you get this resultant line. You connect them.
This is so.
So it's like saying, imagine driving. If you were starting with vector A, you're driving along that distance, and then you turn and you drive along B. Isn't that the same as starting at the end of A and ending at the, or starting at the beginning of A and ending at the end of B? Do you guys see? So you just connect them.
Where's the C then?
Okay. So this would be A plus B. So I think this drawing is a little bit wrong because they should have made this A and this B. That's fine. All right, the other method is the parallelogram representation. So it says in this representation, each vector can start in their standard form with their initial points at 0, 0. But then you form two sides to create a parallelogram. So let's say, let me draw it out so you can see how we would start. So let's say we have a vector here, and we have a vector here. And this is vector A, and this is vector B. What you do is you move A, you move it over here. But you also move B over here. And then the resultant ends up being directly in between. It's right here. This is A plus B.
Oh.
But it's exactly the same as what we just did on the other one. Does that make sense? It's just a different drawing. You get it? All right, so the really easy thing, though, I'm going to show you this real quick because this is on your homework. So if you have 5 and 2, 5, negative 2, and negative 3, 4, if I ask you for U plus V, it is not rocket science. It's exactly what you think it is. It's taking the 5 plus the negative 3 and the negative 2 plus the 4, and you get 2, 2. Can you all handle that? Or if you have 4u, it's going to be 4 multiplied into the 5, negative 2 vector. So what do you think it's going to be? 20, negative 8. Not hard. So you can have combinations of those things. You could have 3u plus 2v. Would you know how to do it? Yeah, you find 3u, you add it to 2v. All right, so it's not hard. All right, let me pass out your homework. Hang on. Hang on just a sec.
You don't?